Welcome back, everyone. Today, we are taking a wildly fascinating journey into a thought experiment that turns absolutely everything we know about space completely upside down. We're going to look at the universe through the geocentric mirror and ask a totally mind-bending question: what if Earth suddenly became the center of the universe? It's a reality-breaking hypothetical for sure, so let's map out exactly what that would look like in today's explainer.
I mean, seriously, what if everything actually revolved around us? Just for a second, totally strip away modern science. Imagine waking up tomorrow and the fundamental mechanics of the cosmos have just shifted. Suddenly, our tiny blue planet is the immovable anchor of the entire solar system. It sounds like the plot of a sci-fi movie, right? But exploring this terrifying scenario is actually the best way to truly understand the delicate, precise mechanics of our real universe. All right, let's start with Section 1, our current solar system and the heliocentric model. So, to understand what we're about to break, we kind of need to establish our baseline reality first. On the left, we've got the heliocentric model. That's our actual reality. It's sun-centered, it's orderly, and it's entirely gravity-driven. Because the sun contains over 99% of the mass in our solar system, its massive gravitational pull just keeps everything orbiting smoothly. Now, on the right, you see the geocentric model. This is the historical, Earth-centered idea that humanity believed for literally centuries. In our thought experiment today, we're going to force this geocentric model into existence and just see what happens.
Moving on to Section 2, breaking laws of physics and shifting gravity. Okay, so this is our inciting incident. If Earth magically becomes the center of the solar system, we explicitly have to break our current laws of physics to make it happen. Step 1, fundamental physics completely shatter. In reality, smaller masses orbit larger masses, right? Earth is absolutely minuscule compared to Jupiter, let alone the sun. So actually, for the sun to orbit the Earth, step 2 kicks in. Gravitational forces would have to shift instantly and unnaturally. Earth's mass would need to magically exert a pull millions of times stronger than it currently does, or the entire fundamental nature of gravity would just have to invert. And the millisecond that invisible change happens, step 3 takes over: massive instability. That delicate mathematical balance that keeps planets floating smoothly through the void? Yeah, it's shattered in an instant.
Which brings us to Section 3, total solar system chaos and unpredictable orbits. If we zoom out from Earth to witness the macro-level effects, it's literally sheer cosmic disorder. Without the sun acting as our central anchor, planetary orbits become completely unpredictable. Massive gas giants like Jupiter and Saturn would start severely interfering with each other's paths. Moons would be violently thrown off course, some crashing into their host planets, others just flung out into deep space. In the asteroid belt, those rocks go completely rogue, scattering everywhere like a giant game of cosmic billiard balls. Comets become totally chaotic, speeding through the inner solar system like unguided missiles. Ultimately, this all leads to the complete structural collapse of the orderly solar system we've known for billions of years.
And that drops us right into Section 4, catastrophic consequences for Earth. So we've seen the massive macro scale, but let's zoom in on the direct environmental consequences hitting ground zero: extreme gravitational stress. If Earth suddenly becomes the gravitational anchor for the entire solar system, or even if we're just subjected to the chaotic, unpredictable pulls of massive planets whizzing by in their new orbits, the physical stress on our planet would be frankly apocalyptic. The tidal forces alone would be unimaginable. We wouldn't just see changes in Earth's orbit and rotation, we would literally see the Earth's crust buckling. We're talking about global earthquakes, hypervolcanism, and oceans rising into mega tsunamis that are miles high. The environmental consequences would render the planet entirely uninhabitable in a matter of days, if not hours.
Let's shift over to Section 5, the long-term cosmic fate and the ultimate outcome.
Okay, so our planet is facing utter catastrophe, and the other planets are running completely wild. But that brings us to the absolute biggest missing piece of this terrifying puzzle. Where does the sun go? I mean, it's the most massive object in our neighborhood by far. If it's no longer the anchor, what happens to this colossal burning star now that it's forced to orbit the Earth? Well, this erratic new setup creates a completely bizarre energy distribution. The sun's chaotic shifting around the Earth would cause deadly, unpredictable changes in light and heat. Picture this: 1 month, the sun might swing terrifyingly close to Earth, boiling our oceans and scorching the atmosphere. But then, the very next month, it might get flung way out past the orbit of Mars, plunging Earth into an instant, deep freeze ice age. The stable, continuous stream of solar energy that has allowed life to thrive on Earth would be totally replaced by this agonizing strobe light of freezing darkness and incinerating heat. Eventually, the system has to settle its energy somehow, and the long-term consequences leave us with two very grim options for the celestial bodies in this highly unstable scenario.
Planets escape or planets collide. The chaotic gravitational slingshots would likely cause some planets to reach escape velocity, tearing them entirely away from our system to wander the Milky Way in dark isolation as rogue planets. For the others, their paths would eventually cross. We would see catastrophic, world-shattering collisions, turning entire planets into nothing more than swirling clouds of molten debris. Phew, okay. Section 6, Why Science Chose the Sun, a Historical Perspective. After witnessing the inevitable collapse and explosive destruction in our little thought experiment, let's safely return to reality and see how humanity actually figured all this out. You know, in ancient times, the geocentric idea just made intuitive sense to early humans. You stand on Earth, it feels totally still, and the sky seems to move around you. It was a hopeful, kind of self-important view of our place in the cosmos. But during the scientific revolution, pioneers like Copernicus, Galileo, and Kepler began observing the real movements of the planets, and they realized, wait a minute, the math simply doesn't work if Earth is in the center. By the modern era, with the discovery of gravity by Newton, the heliocentric model fully replaced those old ideas. Science didn't just choose the sun because the math was easier, it chose the sun because it was literally the only way the universe survives without completely collapsing. Ultimately, it all comes down to gravity and balance. The heliocentric model works purely because of the absolute necessity of these two forces in space. The massive gravity of the sun is precisely, perfectly balanced by the forward momentum of the planets. It is this stunning, billions of years old cosmic dance that requires exact proportions and masses to keep us from either freezing in the void or burning up in the sun's fires. Which brings us to a final thought for this explainer. If our orderly solar system relies on such a precise, delicate balance, what else in the universe is resting on a cosmic knife's edge? Think about the supermassive black holes at the center of galaxies, or the fragile atmospheres of distant exoplanets. Our reality is a wonderfully fragile, perfectly tuned system, and I really hope this thought experiment has given you a profound new appreciation for the quiet, gravity-driven order of our universe. Keep questioning, keep looking up, and I will see you in the next explainer.